Hello guys, before we start, let me introduce myself. I am a professional big data trainer and working in the big data industry for last 8 years. Teaching is my hobby, that's why I'm creating these kind of videos. In my training program, first I work on theory part, then work on practicals. Each training program contains at least 100 to 150 practicals coding examples, and after that I work on industry projects as well. I also work on interview question after completing all the subjects, so please be connected with me. Okay, so before making any delay, let's start today's topic. So today we are discussing about what is Spark and all. So what is Spark? So Spark is an open source cluster computing framework for real-time processing. So open source means you can download it from Apache website and you can directly use it in your computer, and you can also do some enhancement as well. That's called the open source. Another thing is the real-time processing. So if there are two kind of processing in the market, one is the batch processing and another is the real-time processing. So let me try to differentiate both of these. So in the batch processing, what happens, let's say you have a pool of water, and here I'm considering water as a data and pool is a file system, which can be your HDFS file system, Amazon S3 file system and all. Now let's say in every morning you take a bucket of water from this pool. So here bucket is a batch and every morning will be called an interval. So this was the example of batch processing. In real-time data example, let's take a similar example in which we have a water supply pipe. In this pipe there is a one source which is injecting the water into it, and water is coming out to the ground from another end. Now let's say if you want to collect some water, that's the data in our case, then you can collect into your bucket from open end. But whenever you remove your bucket from pipe end, water will be started flowing on the ground. So in real-time data processing, you can process data for a specific interval, but in batch processing, every time you need to process complete data. So if you are doing any kind of transformation in batch processing, that will be applied on the complete data, and if you want any kind of processing on real-time basis, that will be applied on a data which is coming on that specific time for that particular specific time. Okay. Now next thing, Spark provided an interface of programming entire cluster with implicit data parallelism and fault tolerance. So your entire cluster means Spark can launch tasks on complete Hadoop cluster, which can have multiple nodes, thousands of nodes. And we know that HDFS provides its fault tolerance, but Spark had its own way of doing fault tolerance. So it means when we use Spark with HDFS, we will have two levels of fault tolerance, one from HDFS and one from Spark. So we'll understand this later in future videos, how it's actually achieved with the help of Spark. Data parallelism. So data parallelism means Spark execute tasks parallelly. With this approach, it get high performance. Right now, in big data market, everyone is going with Spark. This is the power of Spark. We will get to know why everyone is going with Spark. So Spark has a power, right? And we will understand that power in future videos. Now let's talk about some key features of Apache Spark. So Spark has so many features. I try to list some of them here. So one is the polyglot. So polyglot means you can write your Spark application in any of the 4 languages. You can directly use Spark API in your Scala, Java and R API. So engineers from Scala, Java, R and Python background can easily understand and use Spark. But I recommend to use Spark with Scala because Spark in itself is written in Scala. So when we work on any open source framework, then sometime we have to understand its internal functionality, and sometime we need to customize some existing API. In that case, we should be able to understand Spark Scala code. Below are the example of filter, transformation, and all. And these are written in the language called Python, Scala, and in Java. This is just a small example, so I will explain this in future videos. Now another feature provided by the Spark is the speed, and this is the actual power of Spark. So Spark runs up to 100 times faster than Hadoop MapReduce for large scale data processing, and these performance is achieved by these two reasons. So one is single stage for multiple tasks, and store immediate data in memory. So stage is a terminology specific to Spark. We will understand this later. And second is except MapReduce. A Spark task store intermediate data into memory, that is called the RAM, physical memory. So if you remember, when we were working on MapReduce, we came to know that MapReduce job gets broken into multiple map and reduce tasks, and mapper gets written onto the disk. Mapper outputs is written onto the disk only after it gets transferred to the receiver. So before transferring the data to the reducer, first mapper writes data onto the disk. Only after it gets transferred. Okay. So read write from disk is slow as compared to read write from RAM. So mapper in the MapReduce rewrites the data from the disk, which is comparatively slow in Spark, because Spark's task store intermediate data into the RAM. So data transfer in between multiple Spark tasks is fast as compared to MapReduce. Another is multi-format support. So Spark can read or write data from these given formats: Parquet, JSON, Hive, and Cassandra, and HBase as well. And another thing is the lazy evaluation. So lazy evaluation, this is the another power. So Pig also provide the lazy evaluation. Spark also provide the lazy evaluation. So lazy evaluation means I know what to do. Wake me up when you really need it. Okay, if you have assigned something to your if you have assigned something to someone, and he will not do right away, he's waiting for the final call. So that is called the lazy evaluation. So I have one example for lazy evaluation. So this is desirable than evaluating each transformation done by one, is because when you wait till the end, you have the whole DAG to look at, and the information can be used to optimize the computation that needs to be done. So means lazy evaluations, the main purpose of the lazy evaluation to keep the performance. You are waiting for the final instruction. Let's say you are getting this instruction since morning, and so instruction can be changed after some time, right? In the morning you are getting some instruction, and in the noon you are getting other instruction. So if I give you an example, let's say your father tells you that go to a place X. In the morning he's saying that you should go to the place X, and after that he decided that I think you should go to the place Y. So assume that if after passing the instruction, after your father gave the instruction, if you started your journey, then you just started to place X, but your father changed his decision and he decided no, go to the place Y. So this is the power of Spark. This might be a silly example, but it will still help you in seeing how lazy evaluation could be benefited. So let's say you have transformation like this: list 1. So list 1 equal to list.map I is equal to I into 3. So in which what we are trying to do, we are getting element from a list, and for each element we are replacing every element after multiplying into 3. Let's say if your element is R1, 2, 3. So if you have 1, 2, 3 in your list, so in list 1 you will get the 3, 6 and 9. right? And the second line in the list 2, what we are doing, we are adding 3 in each element from the list 1. So what it will do, if it is 3, 6, 9, then it will be like 6, 9 and 12, because we are adding 3 in each individual element. And in the step 3, what we are doing, we are dividing every element from list 1 by 3. So after all, we are dividing 3 by 3, 6 by 3 and 9 by 3. And if we collect, and the final, and these are the instruction you are getting. Okay, these are the instruction, and this is the action. So lazy evaluation means the complete tag will not execute until you give the action. So it waits for your action. Okay. Now let's assume the original list is used with several millions of elements in it. If there was no lazy evaluation, we would have done such use computation 3 full times. If we assume that it takes 10 seconds for one such list iteration, it takes 30 seconds for this whole evaluation. Now using lazy evaluation, Spark can figure out that those 3 transformations can be combined together into a single transformation like this. List 3 equal to list.map I is equal to I plus 1. So what does it mean? It will compile these statements, it will create the DAG, and it will create the final program. So all these things leads to this. We just need to add 1 into all the elements, right? So this is the list 2 or step 3. This is the list 2, not the list 3, not the list 1 actually. And then it will perform that action just one. This will be done in just one iteration, which means it will take only 10 seconds of time, and that's how you get the performance and efficiency, right? So here is another example for lazy evaluation. So lazy evaluation means that Spark does not evaluate each transformation as they arrive, but instead fuse them together and evaluate all at once, as an action is called. The benefit of this approach is that Spark can make optimization decisions after it had a chance to look at the DAG in entirely. This would not be possible if it were to execute everything as soon as it got it. As a result, a large volume of network can be avoided, which otherwise could have caused serious bottlenecks. Suppose we have a file words.txt containing the following lines: line 1 word 1, line 2 have word 2 and word 1, line 3 have word 3 and word 4, and line 4 have word 1. Next we apply the following operation. So we are just reading the file and applying the filters. So we need a line which contains the word 1, and after that we are saying that we need just first line. Okay, so output will be line 1 word 1. So if Spark were to evaluate each line immediately, it would end up reading the whole file, then applying a filter transformation and then displaying the first line from the filter result. So this would mean a lot of extra work and unnecessary memory utilization. On the other hand, in lazy evaluation mode, Spark first build the entire DAG, and then using optimization techniques, it understands that reading the entire file is not necessary. The same result can be achieved by just reading the first line of the file. Real-time computation. So Spark computation is real-time and has less latency because of its in-memory computation, Hadoop integration. So Apache Spark provides smooth compatibility with Hadoop. This is a great boon for all the big data engineers who started their careers with Hadoop. Spark is a potential replacement for the MapReduce function of Hadoop, while Spark has the ability to run on top of Hadoop. But Spark is not limited to Hadoop itself. So guys, that was from today's topic. Please do write your suggestion and comments in the comment section, and please not to forget to subscribe my channel for getting the latest updated videos. Please click on the bell icon. Keep watching. Thanks for watching.